Deepa, and good afternoon, ladies and gentlemen. On behalf of TMA, I would like to welcome everybody to the knowledge sharing session hosted by Operation Excellence Management Group in collaboration with the Israel Economic and Trade Mission in Thailand today. We have long been talking about Industry 4.0 and Thailand 4.0, but do we really know what to achieve that goal? Today, we will be focusing on these two things, the knowledge from the country that has been there and mostly done that like Israel. Joining me today are Kun Bantun Porapakha, Dr. Maloney, Economic Counselor and Head of the Israel Economic and Trade Mission in Thailand. I would like first to turn to Kun Bantun to introduce why we would like to focus on this matter of industry in Thailand.
Okay, สวัสดีครับ Good afternoon to everyone. As today, customer behavior in the market change. They change their demand quickly with more complexity. They will accelerate to our rate of product and service chain faster. Business and manufacturing also need high innovative and fast moving product and service to respond to the customer change. Moreover, in this COVID situation, changing from the customer effect to the supply chain, we saw some product or service reduce their demand sharply and some increase dramatically, which also affect to the raw material supply, production technology, and also other in supply chain. So today, Industry 4.0 revolution is a key importance to gain more competitive advantage of business doing, especially focus in both terms of flexibility and sustainability. First, about the flexibility, the smart manufacturing able to help us to be responsive to the customer faster, more reliable, and be predictable the customer want, and adjust our supply chain responsively. Example, if we can monitor real-time visibility of raw material, work in process, stock of finished good, then AI and machine learning able to reassess or replan our activity. That very helpful to us. The second, about the sustainability, we can make every process more efficient, cost down, increase productivity up. So our organization is to market condition correctly. So Industry 4.0 expert talk today should help us to see the big picture, benefit, use case, and also can see how to implement the Industry 4.0 tool in the real one. Today, I have to say thank you to Mr. Dagan, to Mr. Akmon, David Porat, and other speakers to help us to organize today's event and also share their experience to us. Thank you very much.
Thank you very much, Bantun. And now may I ask Mr. Aloni to say something about the collaboration and what to expect from today's session. Second, please. Kun Dagan คะ
So hello everyone. Thank you very much for joining our event today. For those of you who doesn't know me, my name is Dagan Aloni, and I am the Israeli Economic Counselor to Thailand. I've been here for the past 3.5 years. Our mission in my office is to try to assist Israeli and Thai organizations from any kind and sort to learn from one another. What we're doing here today, to establish long-term partnerships and to solve challenges that both Israeli and Thailand are facing, and usually by using the most recent technologies. Today should be a great session. I hope you will enjoy. We have great speakers and great technologies, and I think it should be very beneficial to everyone. Alongside our difference from TMA, we will try to touch and explore the challenge of today's industry, both in Thailand and Israel. I'm sure that everybody are aware and feeling it on a daily basis that innovation and technology are everywhere now. each of your organization now listening to us are trying to adapt to the new era where if you don't move forward, there's a very good chance you will start moving backwards. But it seems that the industry has a more crucial challenge than other sectors and industries. If we take banks and insurance companies, for example, they are today in Thailand, for example, spending a lot of money to develop digital products, lending platforms, making money out of their customer data, and all of this in order to increase revenues and increase market share, which is a good thing. The telecom sector, our friends from True, AIS, DTAC, are putting a lot of funds in the 5G technologies, enterprise solution, etc. Now, no doubt all of this is very important. But none of these major sectors I just mentioned, I think doesn't face the challenge of the industry. Because the way the markets are built, and because the country's regulation, in the short term, Thai banks and telcos will not fall because they didn't adapt to today's technology fast enough. Maybe in the long term. However, for the industry, it seems a bit more crucial. Lower salaries, lower cost of manufacturing in the countries, even in the neighborhood, if you take Vietnam and China, for example, together with the rise of e-commerce and low cost cross-boarding shipping, it's very easy to ship cross-border today, make it a mission to the factories all around the world, and in Thailand specifically, to be more efficient, to increase productivity, to lower costs in order to be more competitive. And it's whether it's coming from the automation side, implementing automation, or by preventing the next broken machine and factory shutdown. So the challenge today is not being able to adapt to the trends of technology trends today. This is the challenge all over the world. And this is what we will try to explore together today, to see how it can be achieved, how does Israeli succeed and failed in the same place sometimes, and what should maybe not the biggest corporates, but maybe how does a medium to smaller companies start this journey. So I really do encourage everybody who listening today to use the Q&A buttons below. The speakers today will be very happy to reply. This is everything is for you that are listening back home. Me and my team are in Bangkok. For any question or assistance needed after that, please feel free. And I would like to finish by thanking very, very much to our partners from TMA, Kun Manwira, Kun Bantun. Thank you for your great partnership. This should be fun. So, Kapun Makloy Nakat.
Well, once again, thank you very much, Ms. Wanvira, Mr. Bantun, and
I think that maybe now Dr. Pichaya.
Thank you much for turning this to me. Thank you.
Today, our speakers will share the information of Industry 4.0 technology in Israel and how can Thai companies in several industries utilize that technologies. On the topic, what Thailand should do in technology and innovation for operation excellence. Now, please join me welcome Mr. Agman David Porat, Head of Industry 4.0 Innovation Lab, ex-co-founder and CEO of LED Lab, the Industry 4.0 Innovation Lab. And the moderator of this session, Assistant Professor Dr. Pichaya Ratchadawong, Operation Excellence Management Group of TMA. Please welcome.
Hi, everyone, and good afternoon to everyone. I'm a lecturer at the Faculty of Engineering, Chulalongkorn University, and the things that we concern most is today is about how the society in Thailand adopt and understand the meaning and the usefulness of the ID4. Can you please help us explain or elaborate this on topics about the ID4 concept in Israel and tell you a little bit more about your company, please? Ahmed, please. Ahmed, unmute Ahmed. Unmute Ahmed. Unmute.
Oh, sorry. Thank you. The mute thing is always something. So I'm sharing also my screen. I hope you can see it now. I just want to make a correction. Well, first of all, I want to say thank you very much for hosting me and for having this conversation. It's very interesting for me as well to see what's going on in Thailand. I'm coming from a company called UCT, which I'll explain about them, but we also have facilities and we're opening another factory now inside Thailand as well. We're moving some of our facilities. I just want to make a small correction. The Let Lab is not X. I'm still the founder of Let Lab and it's still active and we're doing investment in startups. I didn't make correction. I thought in the beginning the X is like exhibitor or something, but it's okay. Having said that, I'll tell you a little bit about us and who's UCT and why do we feel that we are connected to the Industry 4.0. So I'm running an innovation lab in a company called UCT. UCT is a $2.2 billion company doing ultra clean gas boxes, everything from the component itself all the way to the ultra clean room and caskets by themselves. I'm running an innovation lab. So we decided, even before we became UCT, up till April last year, we were only a $200 million company. So it's like a small medium company. And during that time, we decided to invest in innovation and specifically in Industry 4.0 to boost innovation both in our product and in our factory. So we opened together with the Israel Innovation Authority an innovation lab focused on Industry 4.0. We invested in augmented reality, AI, robotics, and so on. It's a program where we invest in startups up to 1 million. It's like $300,000 US, which we are increasing now to having seed and up to $1 million per startup. It's we don't charge, we give free office, and the whole point is to find a startup and a solution and combine it with needs that we have inside the factory or in our products. I constantly go and meet with startups and entrepreneurs and state-of-the-art innovation that is out there. And I go ahead and meet also a lot of factories, and we go ahead and see what are challenges that they have and what do they really implement in terms of what is going on. We give our factory as a playing ground for startups and technology enablers, from AGVs and robotics and automation and machine data. Basically, we allow other third parties, technology people, to test their technology internally. So that's about the factory. First of all, in the factory, we are constantly implementing as an innovation lab, Industry 4.0 technologies in our factory. But both in our product, this is a gas box, a very large gas box, an example of our products, a variety of valves, fittings, and flow systems. We do everything here, but also the product itself, we knew Industry 4.0 means also that, okay, if we sold to a distributor or sold to a distributor and somebody eventually implemented, now taking the valve and making it a smart valve, a valve that is, these are valves that are sitting inside industrial use cases, inside semiconductor, oil and gas. These are industrial valves. So obviously we thought we need to improve and make our valves smarter. And I definitely recommend any one of you who is selling a product that is eventually the consumer buys it in more than $300, it's worthwhile to add few dollars and make it already connectivity. Moving from selling only a product to suddenly selling a service. In our cases, okay, the valve can know when automatically shut it off. It can know when it's going to die or when there's going to be a leakage. We can start moving from selling only a valve to selling a service. And this valve got a lot of rewards. We were first to the market to come out with an approved valves for the specific markets. As an innovation lab in the Industry 4.0, we went ahead and we mapped all the startups and also technology enablers that we have inside inside Israel. Later, we did also the same thing for Singapore, and we're looking at other areas. But what I think is interesting here and what we can see is that we see a lot of startups that are in IoT. Basically means visualization of the factory, extracting knowledge of the factory, or making your product, like I showed you with the valve, making that in the industrial Internet of Things. We see a lot of robotic and automations. And I'm talking about either hardware or software, like the brains. Like robotics is a promise And many of you as factories, I imagine, already started to implement cobots and cheap robotics that in the past would cost about, I don't know, $300,000 at least in a year. Now, I imagine you're doing robotic projects, some of you for a fraction of that cost, and you can implement it in a week or 2 weeks or a month. So in Israel itself, we have a lot of additives from 3D printing of electronics, 3D printings in microns like nanofabrica, 3D printing of biological items, and of course 3D printing of plastic and metals. It's very interesting. Anybody who's doing, we are doing flow solutions, and flow solution is moving gases and fluids through systems. And 3D printing, those who know, there's advantage for the flow itself. This is a great example that maturity in the computing and fabrication, the printing of the 3D printing itself, allows us to start thinking about new values for our customers. And it allows us as a company to go to our customers and start talking about futuristic products that we can literally produce and do internally and 3D print it. Cybersecurity, that's something big. And I imagine the same is happening in Thailand. It depends on the size of the company, but companies are becoming, people are hacking them and then holding them hostage and says, okay, this main machine, I'm holding it hostage unless you pay us. And usually it's worthwhile paying. So a lot of money is being spent also on security to protect the PLCs, which basically is the computer that sits on the machine, right? It was slow computer, stupid computer, and hackable one. So they're being improved in the networks and so on. And Israel is very strong in cybersecurity, and many startups pivoted into that. Also with the industrial IoT, companies who did industrial IoT pivoted, did IoT, pivoted to industrial IoT. Artificial intelligence, that's huge, and we can see it also in a variety of locations. AI is a real tool that can be implemented in a variety of different areas. For example, quality control, workers who are looking at the product itself on the line to make sure that it was produced correctly. Many companies are moving it now into vision. Other AI for predicting when the machine is going to fall, or when rotary system. Rotary system is already becoming a commodity. Not many people are using it, but it's already very, very common and useful, and the benefits are shown there. Of predictive maintenance for some of the machines, rotary, vibrations, and other locations. So it's using with AI, and we can see some examples. Predicting quality, QC. A company who is doing process, and we can see them in the end. You can predict when the quality is going to be reduced. You can predict when you're going to have shortage in your warehouse. You can predict what's going to be the demand of your customers. So AI is being used in a variety of different areas, from sales and marketing, but we're talking here in the manufacturing. Sensors and so on. The important thing also on our side is technology enablers and supporters. We noticed that along the year, more multinationals are putting the focus on Industry 4.0 and having new tools and licenses and products for them. From the visualization like PTC, Siemens, Mainzfeld, right? Siemens is doing, I think, one of the largest PLC providers. I think 11 billion or something like that, and from computers for machines, PLCs. All those PLCs are going to be connected to the cloud. So I recommend definitely the SMEs that are listening to this podcast to also check who are the supporters, finders, technology enablers, government agencies, those who care about putting their technology in your factory. Many cases, for example, and we did it here in Israel on 5G, on robotics and automation, we're going to see it here soon. Those technology enablers want the first customers. They are willing to give you the products much cheaper. They're willing to give you the service for free. They're willing to give you the integration for free. Our smart valves, we did at the beginning completely for free, together with huge companies like Siemens, Samsung, and others. Basically, they need a partner to implement their IoT, and you need a partner for that as well. So I definitely recommend you to check who are the parties of interest that they want to expand internally, and they want to show other customers that they did digital twin, they did augmented reality, they did other items that helped you. Okay, regarding our factory, so we have hundreds of CNC machines. What does it mean IIoT? All of the machines are connected, and we're measuring exactly what's the OEE, overall equipment efficiency, how much is each equipment is efficient. Those of you who have only, I don't know, let's say you're doing CNC or injection machines, and I imagine you have maybe those who don't have a lot, like 5, 3, 4, 5, you probably didn't connect them because you didn't see the point. But now there is a point because you can use the big data in the future to understand exactly when the knife in the CNC or any other product is going to be manufactured not correctly. There's additional value of connecting it and seeing the value. Obviously, one of the first values, especially in companies like us that have many CNC machines, is that you have visibility. And workers are competing one against the other, even if they don't know it, about the efficiency. Because the manager comes inside and on the wall, they can see exactly which machine has been working, who's working it, and what's, you know, how many units worker A did and how many workers B did, right? And the workers know it. So they cannot run the machine and go to a smoke or do something like that. But most importantly, we get more data, and then we can ensure more quality and provide better usage. All the new machines that we buy, obviously we want to connect them to we're looking on the digital side and the OT side, the operational side. If we're bringing a new machine, how would that connect to our digital side as well? What data can we extract from it? How can we measure our cycles and our efficiency? Every CNC is a tool that cuts inside the metal. Those tools that cut inside the metal, they have a disposable item that basically cuts the metal. It's either like a driller in the regular driller that you use at home. We used to host them, you know, like this. This is what I imagine many of you are doing. 10 years back, this is not new. This is not industry. This is 10 years. This is before the Industry 4.0 was mentioned. We already moved to tools like this. And I'm putting this inside because this is it's relevant to the logistics, which I understand is relevant for all of you. What this tool is doing, instead of having all the tools, you know, in boxes and somebody is measuring, okay, you're going to cut this tool, then take this cutting knife to that machine, and how many tools do we have, and so on. Instead, a worker is going to the machine saying, hey, this is what I'm going to produce. The machine automatically opens the right drawer and format the right box, so the worker will take the exact knife. Now, after the minute he took that knife, this machine tells to our supplier, hey, order one more knife, right? So this is the supply chain, digitizing the supply chain. We don't need a person to measure and write down what is being used and is it being used properly and so on, then count and then call our supplier and telling, hey, give us more knives and so on. No, we digitize it. It's completely automated, so we make sure we don't make mistakes and manufacture for 2 hours something with the wrong knife and so on. And automatically it goes to our suppliers and make sure that we'll never miss it. It's a complete win-win situation. Another example is moving everything to digital, right? No paperless. So we used to have, and if you're doing CNC machines, well, even if you're not, I'm sure you know the quality control when you're manufacturing, either you're doing it for every item, you're doing it to every 50 or every 1,000, doesn't matter. You're doing quality control on it. And either you're putting it in a digital system or you're doing it a manual system. Most companies are doing it in the manual system because of the challenges. So we are moving everything into the digital, and then the worker would simply put the item, he gets all the digital items. Obviously, we also have CMMs, which is much more accurate. It's a tool that measures. I don't want to go into it now. Every new machine that we buy, it comes already with integrated robotics. So it's machine tending. Here we see an example how easy it is. Okay, this guy bought the robot. This is 3 years back, and I know that Thailand is a country that is adopting cobots. So I imagine many of you know this as well. But this is in 3 hours. The guy was able to show us a use case of machine tending. The robot puts the item in the machine and takes it out. Now, you'll be surprised, but it's not surprised. You know, humans are not efficient at it. Sometimes they go to a break, sometimes they go to another location. A third of the time, the machines are empty. I'll show you 2 more examples. Let me just play this one and this one. This is an example of a process that we moved into Thailand because we have a manufacturing site and we decided to move some of our labor intense task into Thailand. which is, I think, an advantage for your side if you're going to start automating your factories, just like East Europe or Central and South America or China, who in the past, all the companies moved their manufacturing to cheap manufacturing areas, but then they invested the most in making those factories automated, and then there's no reason in taking them out. So what we're seeing here, this is a completely manual state of people putting items inside. And with the cobot, we actually did it completely automated, very fast. And as the lab, we were able to measure, wait a minute, are the workers, are they happy with it? In the beginning, obviously, they think that it's going to replace them immediately, very fast. They understand nobody is being replaced, but the dirty, the dangerous, the dull task is being replaced with the robot. And suddenly they have more pride in what they're doing and more will to come to work and enjoy the work itself, because they're not doing the dirty and dangerous task. We obviously checked AGVs for washing the floors because we constantly watch it, and AGVs for transfer of the materials. This market is becoming, very mature, especially now with the COVID, which forces a lot of factories to implement automations, transfer, remote presence, and so on. I expect this to only grow. We did a study about automation in Israel and its adoptions. And we went to the Israel Export and Import, and we contacted a lot of the integrators and robotic integrators to see what they think about, how much robotics they implemented. And even though there was a slight decrease in robotics adoptions compared to 2019, but compared to the entire market, it's higher. So the entire market, because of the COVID, went down. And the robotics also went down, but not as significantly as much. Actually, there was more implementations. Because of the coronavirus, people are implementing more and more automations, and we saw it. And even in Israel, we were surprised to see that people are actually using exoskeletons. Exoskeletons, not many people are talking about it, but it's because it's not common use, but it's like wearing a robot that helps you lift items and the heavy weights, and it would reduce some of the force and medical damage to workers who need to lift a lot of the items themselves. So it's even been used by one company in Israel, but still very young. Industrial robots, still the majority of the market, but and still growing. But cobots, which are robots that work together with humans, are the fastest growing. Still small, but fastest growing in it. I think the most important thing from our survey was the fact that almost all the factories are looking at implement robotics. Almost all of them implemented few cobots or robots on some location, at least the big ones. And the integrators, all of them reported that there is an increase in the demand for robotics in their factories as well. I'm going to finish also about the part of what the government here is doing forward. So you notice the government helped us to establish what is called here the LET Lab, where we invest in startups in Industry 4.0, where the government takes the risks. But the government is also investing a lot in the factories themselves. And they're calling factories and telling them two things. One, if you have a new product in mind, we give you money to develop it. Second, we want our factories to be more advanced. We would give you guidance, we would give you money to upgrade your factory per project. And they establish, and here it's in Hebrew, you don't understand it, but it's the Institute of Manufacturing, Institute of Smart Manufacturing here in Israel. And it does three stuff. It does consulting and implementation. Okay, it's a knowledge center, it's a demo center. Demo centers, a physical space, which I don't know if you have in Thailand. Singapore, for example, it's called A-Star, and in the US and in Germany, there's also hubs like that. It's basically for all the small factories who wants to understand what does it mean, digital twin? What does it mean, the augmented reality that I can see it? Where's my value? And in this demonstration, we built like a small line to show how the manufacturing is digital, and you can see what's the OE, which item is being used, and you can see vision quality control, and you can see palletizing. Palletizing, for example, is a common robotics that is being spread very fast around the world, including in Israel. In the end of the line, the palletizing itself which usually is 2-3 workers, is being replaced with a robot. So in this demo unit, they are showing common solutions, and there are other items like that, but mostly they are giving the consultation and implementations, and that's foot on the ground going into the factory and connecting them to advisor, and then the government is paying for that advisor, and then it's paying for the changes in the factory itself. It's not completely free. The company pays part of it as well to show that they're serious, but the rest comes from the government, and the company does not need to return it back. It's the government's interest that the factories would be completely automated. It ran a bit longer than what I wanted, but this is what I wanted to show. I wanted to show a little bit about the landscape. I think the future is digital, and I think Thailand is a country that is adopting technology very fast. I wonder what, and I know some of the factories, because we have factories there as well, are becoming more advanced. So I wonder how it's, how it's going to look now in Thailand as well, and how it's going to look in the future in Thailand.
Thank you, Ahmad. Thank you so much for very resourceful introduction to ID4 in Israel. Thank you very much. As I heard from you, I think it's really interesting to hear a lot of new wordings. But the thing that it interests me more is that I hope that one day the machine will not get all the human out of the factory, right?
I don't know. I think every
now you start to have their brain to think on this kind of matter. Oh, this guy is not
right. They are. In let's
really?
say they are right because vision. Let's say quality control with vision. What's that? That's AI. Nobody knows the black box there, but and he's smarter than humans in the sense, right? But people don't realize that even there are companies working on general AI, and I'm not talking about the threats that the factory would decide that he needs to protect himself from other factories. But what's happening now is that you have specific AI, similar to what we have in our brain, specific AI for the language, AI for speech, AI for designing the movement of the robot, AI for mapping the room itself. And each AI is completely different. You cannot use an AI for mapping to start, talking and having wheels. I imagine we still have lack of understanding about our brains itself to understand those core of concepts. So I'm not afraid of that for now.
Let me ask you one thing. In Thailand, we have about 2 million SME entrepreneurs. Okay, most of them, more than half of them at least, they are not very much connected or have some even basic knowledge about the ID4, about the AI, about all the sensor, about the robotic system, things like this. The things that I'd like to ask you is that during this time of the COVID crisis in Thailand, okay, we have a problem of a human. I mean, some workers got infected and the factory has to be shut down, or at least we don't talk much efficiency nowadays. But if we do have an ID4 in Thailand, would it help improve the situation about the requirement of the human? I mean, human work in the factories is number one. And number two, how would we improve the efficiencies in the production line for the SME? And number three that I'd like to ask is about how would be the main benefits for the supply chains? Can you help me elaborate on this matter, please?
So, okay, first of all, regarding the large amount, 2 million is huge. And I imagine many of them are like moms and pop shops or factories, which they have few machines inside. The thing about the Industry 4.0 that it talks about a cultural thing that is happening, and there are drivers for it. And the drivers are happening even if they want it or not. So out of the 2 million, they are competing one another. And some of them are more smarter entrepreneurs, and they would look for the low-hanging fruit. They would look, where can I get a little bit more, manufacture it a bit cheaper, or increase the quality. Where can I put the automation? And they get offers for robotics, and they see the offers for the capabilities of the vision. So some factories are going to implement. And the minute few of them are implementing it, the competitor sees that they implemented, because suddenly, he's producing at higher costs. And this competition and fear of competition as well drives each factory to see, and the CEOs of the factory or the next generation, if it's a family office, it's people who grew up already with TikTok and the phone and apps, and some of them wanted this basics. So even if somebody is connecting, he has a problem with his supplier, and he knows about the digital, and he's implementing some technology, even if he doesn't call it Industry 4.0, but the fact that he put IT system that his supplier would always let him know, when the minute that the truck is going to him, or the truck is being stopped and so on, and he gets starting to get the data, and he gets a little bit of advantage to his competitor, that's Industry 4.0 in a sense. So I believe this is a process in Thailand, which in general is adopting new technologies very fast compared to others. And it's individuals who are comparing, implementing those technologies. And it's true for manufacturing and true also for tourists. But in manufacturing, the challenge is that it's a risk-fear environment. So if you don't mind taking risk, let's say in tourism, and do something like that, because if it doesn't go wrong, it's okay. In the manufacturing, usually it's because of the people, it's much more risk afraid, and it cannot change a lot of the items. So that's the challenge, why some of the factories are not implementing. Fear of cultural change, fear that we're not doing the right job, fear that the worker is going to be replaced, all kinds of those fears. This is why in Israel, they support those SMEs and saying, hey, we'll take the risk. We want to help you. We know you don't have the knowledge. We're going to build a center knowledge and so on. So that's about the competition. I think the fact that you have a large number and the fact that you are competitive would drive companies there to implement robotics, grippers. I'm sitting in front of me, there's a gripper that was manufactured in Vietnam by entrepreneurs, young entrepreneurs, because it's easy, right? They're CNC some machines, buying few actuators, putting Raspberry Pi or whatever, or compute power on it, and you have a product. Downloading for GitHub some code, that's part of the Industry 4.0. Suddenly the small companies can do it. Regarding the logistics, so that's a huge market by itself, and there's a huge startups on it as well. From automating forklifts to a blockchain along the whole process of network. So we'll have standardizations on the quality of the raw materials and subcomponents that we order to make sure that there's authenticity, that it was manufactured according to our specific requirements. It could be compiled inside the blockchain. To be honest, I don't think anybody is really using it across the value chain. It's completely theoretical, just like the augmented reality was theoretical and not many companies are doing it. Now I know more companies are doing the augmented reality, but 2 years ago, not many people are doing it. Now with the HoloLens 2, I hear more and more companies saying that they're using the HoloLens, but still it's not augmented reality is still not there. So the same is, blockchain is even a bit behind there in a sense. But that's part definitely of the logistics. Then there's also the logistics of the transfer between different departments, either for your factory or from worldwide. So that is interesting as well. Specific for Thailand, if we take, for example, the food industry, the oil and so on, coconut, there's transfer of materials all the time, right? So I'll give you an example of a company that did, how do you call it, the wood tray that you put the stuff on it. It's the palleting. They used to do
pallet.
palleting.
Yeah. Okay, yeah.
So
Wood pallet.
this company, pallet. So this company decided, okay, it's a palleting. It's a cheap product. This company decided, okay, we're doing pallets, but we're doing high quality pallets. So let's make this pallet smart pallet. We'll simply put a sensor of temperature inside and so on. And then they pivot their whole product from becoming a pallet company that sells pallet. That's it. Some people return the pallet, some people don't. And the reason that they did it with the sensors, they wanted to see where are their pallets and nobody steals their pallet. But after they did it, they see that it provides value for their customers, and they pivoted their business model to say, okay, I'm not selling pallets. I'm selling you information about your goods. So Walmart, which is buying, I don't know, goods from a producer, it wants to know that the goods were transferred in a refrigerator the whole way. And if it's stuck in the middle, they want to know. And if it wasn't treated well, if the temperature jumps and so on, they want to know. So suddenly, instead of selling pallets to the guy who's delivering the food, they are selling the service to the buyer that, hey, know what's going on with your food and the logistics chain. So I think that's another example of seeing how the whole logistic chain and having knowledge not from the minute I bought the product, but all the way back from the mining company eventually, right? Dig into the, I don't know. Eventually, that's the future of digitizing the whole value chain and then extracting value out of it.
I think this is really good information about on this the pallet. I think I got some new idea on this one also, because from just selling the pallets, you selling the sensor with the pallets, right? And then also they can tell us about the information on the environment that the pallets stay.
Exactly.
I have one more question. Maybe perhaps the last question, if the floor doesn't have any question anymore. If you what if you can't have a customer in Vietnam and they need some information on the they need some information on the how to implement, or they have some problem with their system. It is difficult for you to communicate with them and teach them online. I mean, providing them the instruction on this one. Have you got any problem on this one? Can you tell us about it?
Yes. So actually, we invested also in a company startup doing augmented reality. So augmented reality is being used for remote support, like you mentioned. Okay, then the worker wear a helmet, a HoloLens, and he'll get support, and BP and so on are using it. SMEs, I don't see how they're going to use it or get value out of it. We invested in it mainly not to give support on our products or the manufacturing, but to preserve knowledge inside the factory. Because we are doing training to the workers and the employees. And those employees are constantly being replaced. And we're investing heavily in an employee that most probably he's not going to stay here after 1 year. So we decided to invest in a startup that is doing capture of knowledge using augmented reality. So a worker can see on the machine what he needs to do. And the person who built the tutorial is also a worker. So, but I think that was an example where we jumped ahead of time and invested in a technology that was a bit premature. This was even before the COVID. The startup, as many startups, they failed. So it didn't survive till the COVID, but I think if he would probably raise more. The remote presence is important. But I think what many companies are doing first is, okay, we have a factory in Vietnam, and by the way, in Thailand as well. So I want to see it. The head of the manufacturing wants to see which machine is up and down. This is part of the value that I show, that the machines are being connected. So the first immediate value that many SMEs can do here is get an understanding of their manufacturing assets. What's up, what's down, who's working on them, what's the overall equipment efficiency. Today, to connect a machine, it's really not difficult, and you don't need to pay, expensive fees to companies like Siemens or PTC or others. You can even put, there are tools that you buy, you can put it on the electricity of the machine and extrapolate from that, how many times that machine closed, open, or whatever. So that's about visibility and augmented reality. Augmented reality is going to be used. I have no doubt about it. Preserving knowledge, training, remote support. But from my experience, it was still not there. I'd be happy to see use cases where companies are implementing it in SMEs.
I have one last question. We have two more minutes left. The last question, what do you think about the next phase or the future of ID4? As you have seen a lot of experience around it, what would be the next step of that?
Well, eventually, remember that we said all the way from the coal mine, all the way to our product, we have digitization. It's also a lot about the value of digitize. So I think we'll have, it doesn't matter which product it is. It could be this, it could be my t-shirt, it could be like a headset. We'll have millions of more products. And those products are going to be more and more suitable to each one who buys them according to what they need. And the cost of these products is going to be reduced. And second of all, those products are becoming smarter. So we'll have more products, more connected. Semi, I imagine, is going to continue growing. If we have this valve, for example, behind me, it's going to become a smart valve. You're talking about screens, shoes. It's easy to put a chip inside. This is the first thing I said here, guys. If you're selling something above $300 or definitely $1,000, put a chip inside and put the cellular eSIM inside. So get knowledge from your customers and so on. So I think that's the future. Automation and AI, but basically to extract knowledge of improving optimization, quality. And I hope that many companies will put about on sustainability and environmental an impact their factories.
Thank you so much, Edmond Parat. Thank you very much.
Thank you.
And I'd like to turn the floor back to the TMA organizer. Thank you very much.
Well, once again, thank you very much, Mr. Parat, Head of Industry 4.0 Innovation Lab and co-founder and CEO of. All right, well, I'm back. Well, the upcoming session will be the pitching by 3 Israeli companies on the topic of tools to access Industry 4.0. Before we start the pitching, if you have any questions, please feel free to send it to the chat box. Our speakers will answer them during the Q&A session. Now, I would like to invite the first company, Phenonia, that provides predictive maintenance and analytics solution for control valves. Please welcome CEO of Phenonia, Mr. Idan Khalid. Please welcome.
Okay, we start.
Okay, hello everybody. So thanks you for the introduction. So as you know, I'm the CEO of Phenonia, and I will talk to you about, we are a startup company in the field of Industry 4.0, and I will talk today about what we do in the terms of Industry 4 and what values do we bring for our customers. So first, let me introduce you. The main feature that we are working with is industrial valves. So in this picture, you can see an example of a control valve, which is basically the main asset that we are giving value for, but not only. So let's start by understand what's the problem that we are solving. So the idea is that industrial valves integrity testing is mainly dependent on human component and complex and costly equipment. So the methods today basically is based on periodic testing once every couple of months. The highest frequency that we are familiar with is 6 months between testing to another testing. So this method is basically used since the 70s, and it's the same method used today by most of the plants around the world. So let's understand what's the problem with this known method. The idea is that there is a risk that you have to take, which is what will be fast, what would happen first? Is it the mean time between failure, or it's the time between testing? And looking at the history that we will show later, is still today, there is an average of 5 incidents every year worldwide. in oil rigs on oil refineries. So as we know, just in the last two months, there was at least 5 incidents. The most common that we are probably familiar with is the ocean fire in the Gulf of Mexico, which happened due to underwater leakage of natural gas. So this is the problem that we solve. So let's see about the technology that we innovate. So we have developed a smart sensing solution. We use a method we call deep sensing technology, which is basically sending and collecting acoustic waves and analyzing it with an AI engine. These methods allow us to build an IoT solutions that can monitor the health of industrial valve 24/7. So in this slide, you can see some example of the feature that this solution can bring to the plants. So the more I won't mention each by each, but I will say that the main idea is to detect internal leakage and external leakages, and to track the deterioration levels. This gives the value for the operators to know exactly what's going on inside of their valve, industrial valve, and to prevent the next incidents. So this is the technology and this is the solution. Now let's go and understand the values that it brings for the industry and the use case that it can be used for. So the value number 1 is disaster prevention. As I said, there is an average of 5 incidents worldwide every year. All those examples taken from the newspaper are the results of valve failure. It leads to explosions, fire, it has casualties, and it has the major environmental pollution in history happened due to control valve failures. So all of those events happened when there was periodic testing for those valves, and still they failed in the most critical time. The most common use case in that case that lead to those kind of incidents, it's internal leakage. It's valves that basically should be isolated the flow, but they were not tight. Now, every new valve can be tight, can be as tight as it needed, but when time goes by, the valve tightness goes down, and this is the result. So value number 2, it's basically about sustainability. So I'll give you an example. 3% of the natural gas taken out of the ground worldwide would end up in the atmosphere and not in the edge units that's supposed to burn it. This has happened due to mainly fugitive emissions involve an emission through flange and fittings around the pipelines. So it is worth to mention that today, most of the industry goes to achieve net zero 2050. And by a part of it, so here it's a newspaper in Hebrew from Israel, but it talks about the carbon tax method. So most of the countries go to use carbon tax and to try to achieve lower emissions. So in that case, our solution can help industry to recognize emissions through valves and flanges in a very, very early stage and low rate of emissions. This helps to minimize the emissions and to avoid carbon tax. So value number 3 is cost reduction. So the idea is that this value comes last because human lives and the environmental pollution is more important. But this is a very important value as well, because the idea is that the industry, which is not 4.0, is basically have every industry, mainly the process industry and the petrochemical industry, they have huge amount of waste. This waste can be found in each and every part of the process. And I'll give you some example. In that example, I think, yeah, in that example, you can see how a steam trap leakage looks like. And you can see in that table, you can see the cost of this inline leakage that occurs in steam traps. The cost, as you can see, can get easily to $50,000 a year per one trap. A typical petrochemical plant would have thousands of those traps. So just think about the number. The number gets to millions of dollars easily just by waste of steam and the energy that's used to make it steam. So the idea is that finding those leakages in a smart way, it means like putting sensor where it's needed and knowing automatically where there is a leakage and send the technician to fix it. It's worth millions for plants. Another important thing here is to talk about downtime. So unplanned downtime, which is the very common thing in the petrochemical process, many times it's happened due to unexpected failure in a control valve, in a critical valve in the process. So the average cost of downtime is $3,000 per hour. And it can easily grow into a few hours downtime, unplanned downtime. Every process industry knows this issue. So the idea is to avoid those issues, those downtime have significant cost reduction. Another important thing is about the medium. So anti-chat causes inline leakages that waste lots of, like in the steam trap use case, it causes waste of natural gas and other expensive material. So I'm talking in that case only about the cost perspective, not about the environmental. So in that case, the ROI can easily be huge. I mean, dozens of magnitudes when you prevent an unplanned downtime and when you commonly use this innovative technology to detect those internal leakages. So that's it for today. I hope you enjoyed it. And if you have any question, thank you very much.
Well, thank you very much, Mr. Kalush. Let's continue. The next company is QC. QC is a real-time AI-powered process and quality predictive analytics for the process manufacturers.
Now, please welcome co-founder of QC, Mr. Daniel Berger.
Hello, everyone. I hope you can see my slides. Good morning or good afternoon, wherever you are. My name is Danny, and I'm QC's Chief Customer Officer. Thank you for joining this talk. Today's talk is about leveraging the process data that you are collecting on a daily basis. And by leveraging this data, you are actually able to save millions of dollars on your annual operating costs. I would like to start with the quote on top of the page that more than 50% of the global waste is originated from the industrial waste. And if we translate it to money, more than 860 billion US dollars are lost on an annual basis every year due to poor quality. But the point here, and this quote, by the way, was done on April 2021 by the World Economic Forum. The point is that the industrial waste is just the tip of the iceberg. Because if we look on the entire supply chain, from the raw materials to the end product and beyond, there are so many things that can go wrong through this long and complicated route and can lead to inefficiencies. Those inefficiencies results in eventually excessive waste, that's the number is appearing here, but other inefficiencies result in the rework, the recalls, excessive energy consumption, and environmental pollution. If we analyze the reasons for those inefficiencies, and especially when you do the digital transformation journey and transit into the Industry 4.0 or the smart factory era, we were able to analyze 4 major challenges that contribute to those enormous losses. I'm starting from the left. The first problem is the quality defects that leads to variance between different product types, as well as leading to downtime. For example, in a pulp and paper factory, if there is a tear in the rail, you need to stop the production, the same for chemical plant and so on and so forth. Variance also leads that you will get an increased scrap, the same problem that we highlighted the previous slide that results in a huge loss. The second challenge is the amount of data. So today everything generates data. You can have the sensors, the IoTs, the MES, the SCADA, the historian. The question here or the challenge here is not necessarily how to collect the data. The challenge here is how to make a meaningful insight by correlating the most complicated layers of data that you are already collecting. The third challenge is the laboratory test, the quality measurements that are taken along the production cycle. Today, it is done completely manually. In addition, it's infrequent because it's taken every 2 hours, 4 hours, sometimes once a day. So it leaves you with too many blind spots or spots that you can not know what's going on in your production process. Plus, manual tests usually lead into errors and mistakes. The last challenge is the work shifts difference. At least in Israel, we know that the experienced workers, the older workers, have better skill set than the inexperienced workers, the younger. And what QC helps you with is harmonize the knowledge between the experienced work shifts to the inexperienced work shifts. But as importantly, we make sure that the knowledge stays with the company, and the case that the experienced workers leave the company or retire doesn't leave you vulnerable because you lose their knowledge. So how do we do that? How do we help you save the operational cost that I just described before? I'm going to use a piece of cake, a very tangible example to lead you through and explain you what QC technology does. We are a product or a process quality control technology. And what we do is very similar to predicting and prescribing a baking process. Therefore, I call it a piece of cake. If you want to go and bake a cake, you are going to the grocery store and you are going to buy the top ingredients in the market, the eggs, the flour, the sugar. This is equivalent to the raw materials in your factory. Then you are going to buy the best tools and aids available in the market, like the mixer and the oven, which are equivalent to the SCADA layer, the machines, the automation, smart factory, and so on and so forth. But with the top ingredients and the best tool, it's still very challenging to foresee if the cake is going to turn perfect, because during this long and complicated production process, many chemical and biological processes occur and can influence the outcome. And you cannot guarantee that the cake mixture or texture is going to be as according to your recipe. The sweetness is going to be the same cake as last week. Those kind of challenges are addressed by QC, and what we provide you in our product and process quality control is an early alert. Hey, something is wrong, plus a prediction. Please pay attention. In the next 2 hours, something is going to happen that will lead into a faulty outcome. The cake is not going to turn as you expect it to be. But most importantly, we provide you a detailed prescription, what you need to do ahead of time in order to get the required result of a perfect cake. please add 2 spoons of sugar. Please spin up the mixer 10% up, reduce the temperature, wait with the dough another 10 minutes before you put it back to the oven, and so on and so forth. With this detailed prescription, the recommendations, eventually you get a 0 defected cake. It's important to stress that we harness the artificial intelligence and machine learning algorithms in our technology, but this is to stress also that we are very different than other technology types that makes use of the artificial intelligence and machine learning algorithms. For example, the predictive maintenance. While predictive maintenance, a major objective is the well-being of the machine, QC caters the entire supply chain, and that's a big difference between the two technology types. Another example is a technology called process optimization, also referred to as soft sensor. Again, the advantage of the QC technology is that we cater the entire supply chain, plus we provide a detailed prescription and a root cause analysis. There are other technologies, digital twin, monitoring, and IoT systems. They are all good for their causes. QC technology is a little bit different than those, so it's not apples to apples, and we cater the entire supply chain, as mentioned. We address the continuous and the batch process manufacturing. We don't address the discrete manufacturing. And specifically, you can see here the type of industries that we serve, such as the building materials, the chemicals, and so on and so forth. I want to walk you through a couple of examples, use cases that we are serving today. The first one is a cement plant that we serve in Europe. We are predicting and prescribing a KPI or an objective called 28-day cement strength. A direct contribution of our prediction is a reduction in the energy cost. Now you have to understand that in a cement plant, the energy comprises more than 50% of the product cost. So if we are able to save 10 to 15% of the energy cost, is a substantial operational savings for the company. But as importantly, there is indirect contribution of this use case, where because we reduce the energy usage and cost, we are also able to reduce the CO2 pollution. Now, the building materials industry is responsible for 7% of the global CO2 pollution. So by reducing by double digits this CO2 pollution, you are not only positioning the company as a sustainable and environmental friendly, but you also help the planet. The second example is from the chemical plant. This plant is a food additive plant. And their main objective here was to increase or to improve the yield. In this example, we were able to improve the yield between 15 to 20%, and that's the direct contribution, saving them millions of dollars per year. But as importantly, the indirect contribution was to better utilize the raw materials and avoid excessive usage. So by reducing the use of 30% of the raw materials, we were able to help them still get the desired outcome, but not waste as much money on unused raw materials. So with that, I actually complete the talk, and I would like to reach out to you. We are already serving process manufacturers in Europe and in Americas, and I want to reach out to you and suggest partnership and collaboration in Thailand and Southeast Asia with cement, chemical, the petrochemical, and the pulp and paper industries. We are available later on this platform for meetings, and you can reach out to the team in Bangkok and schedule other meetings with us. Thank you very much for the patience. Goodbye.
Well, thank you very much, Mr. Berko. Last but not least, please welcome Mr. Uri Dubin, CEO from Robot AI. Robot AI is a company who provides service and product of AI-based software to transform cameras into 3D measurement devices. Please welcome.
Thank you very much. And I would like to show you something amazing before I begin. This is my smartphone. and I can grab it. This was amazing. It's amazing human capability to grab objects. We do it all the time, everywhere. But imagine for a second how complex this is for the robot. You need to have some kind of sensors that gives them position, orientation of the smartphone, and then I need to do the motion. It's a very simple task becomes so complex for a robot. So let me share with you how we simplify this. So the problem that we are talking about is huge expectations from robotics. $176 billion of expectations that robot will come to our kitchens, hospitals, stores, everywhere around us, not only manufacturing. But actually what is happening? Many jobs are still done manually. And the big question is why? What is the missing part? So one of the missing parts is the ability of robot to understand human environment. It's called situation awareness. It's usually very complex, not fixed, and it's hard to understand it. The guys in a autonomous cars industry already understood that it's not enough to know my position on the road. I need to know the position of other cars, the distance, the orientation they go, direction, signs, maybe pedestrians. So we build a picture from objects. And this is what is also important for robotics in manufacturing. So there are many solutions to build this picture of 3D objects. People using very different sensors to understand the position of the objects around us and around the robot. And it usually relies on 3 basic technology: projecting light, projecting lasers, or using multiple cameras. And all of them have some kind of limitations, maybe drawbacks, like precision, working distance, or size. Now, what we do, it's something interesting. We look at the humans, and you can do this experiment even right now. You can close one eye and grab an object in front of you. So you don't need, I assume you succeed. So you don't need lasers. You don't need 2 cameras. With one single sensor, you can understand the position and distance and orientation of the object that you grab. And we do it all the time. We can drive the car, and you can do a lot of things. So our brain knows how to decode this information. So we created the software, AI-based, which mimics this brain capability. And what it does, it connects to any camera that you have and give only position of objects around you. It can be something like this: position and orientation of known object. And this is information that we extract from a single image. So this is a very interesting product. It's actually, you can train the system by just scanning the object from different directions using the same sensor. Then you, like a kid, you say, okay, this is my object, this is my object. You label it or tell the computer what is the object they're looking at. We create a model, and then from this, you can extract the position of the objects around you. It does not require any special scanning software, no CAD data, and it could be adjustable to any objects that you have. And it's totally independent. You can do whatever you need. We provide this software solution, and usually if you have for example, manufacturing plant, you can want your robots to work with different types of objects. You can just deploy several post-6D solutions and a single label 6D just to give the robots what the objects they need to work with. This technology has a lot of advantage. One of the advantages is a very good precision. We can work with cameras that can be close, very close to the object, and have sub-millimeter precision. It can work very fast. We do not process point cloud. Also, we are very price attractive, since we only software solution, and it could be connected to almost any camera. And we can deal with all kinds of object types. Also, it's easy integrating the existing robotic solutions that you have. What is needed is a sensor, there's any camera, and a PC. What is happening that robot asks us about position of the object. We take the image and create the coordinates for the object to move and to grasp the object. So from a business side, it's we're looking there and working with companies that produce robots, sensors, and also robot integrators. These companies can create solutions for manufacturing and create a more interesting and more efficient environment. The market we are talking about is a market of not only industrial robots or sensors, it's about job automation. Our solution can reduce the size of the robotic solution, still keeping it smart, and it has profound applications for sustainability, since you can keep your manufacturing local. So on top of this basic capability of detecting position of object, you can build applications like picking in place, bin picking of object, assembly of parts, and doing even communication and new type of robot programming. And we are working with companies in the different areas like Whirlpool, Denso Corporation, Ford Otosan, Deutsche Telekom, and many others doing POCs and projects with us. There's many different use cases that can apply. For example, if you have a company with 500 robots, we can provide a software license for several of them, and you can deploy it in your facility. We have a team of people that are very proficient from Israel, all of us PhDs, most of us, and have a lot of experience in Israeli ecosystem. So the future would like to mention also the same technology could be applicable for indoor navigation and also augmented reality. And the most important, if you know the word, the COBOT stands for collaborative robot. We would like to coin a new name. It's called cognitive robot. And this robot can adapt to changing environment using a very simple camera. And this would make it much more interesting and flexible solution. I hope you have some time, and you can reach me on this email, but if you want, I can show you some use cases, how it works, and I hope it maybe be interesting for you. So this is a basic technology. This is how it works. They monitor some position of objects, and this could be used for pick and place solutions. Then you want to adjust the robot. The robot can pick stuff from it's called bin picking problem, where you can come and pick certain objects. This is how robot recognize them. And it could be extended to logistic applications where you want to pick different packages. And there's many, many different bin picking applications that are around. And we work with different types of robots, usually in manufacturing. We are robot agnostic, and this is what I would like to say. Thank you very much.
Thank you
very much, Mr. Dubin from Robot AI, also Mr. Berger from QC, and Mr. Kalush from Fenonia for sharing us an interesting presentation. For the presentation of pitching session will be sent to you by email.